NASA's James Webb Space Telescope has revealed a new look at colorful auroras, but not here on Earth. Recent observations of Neptune, the most distant planet from the Sun, have shown a sky full of vivid science stretching across the planet's upper atmosphere. These light blue splotches painted all around the planet are packed with information about how the gas giant's atmosphere behaves. Aurorae happens when energetic particles, often originating from the Sun, become trapped in a planet's magnetic field and strike the upper atmosphere. The energy released during these collisions creates their signature glow. However, what has been observed in Neptune is noticeably different from what we are accustomed to seeing here on Earth, or even on planets closer to it, like Jupiter or Saturn. Instead of being confined to the planet's northern and southern poles, Neptune's auroras are located at the planet's mid-latitudes. This is due to the strange nature of Neptune's magnetic field that astronomers are still actively investigating. In 1989, the Voyager 2 spacecraft made a flyby approach that first confirmed Neptune's magnetic field is tilted by 47 degrees. Since aurora activity is based where the magnetic fields converge into the planet's atmosphere, its aurorae are seen far from its rotational poles. With this new data from Webb, the temperature at the top of Neptune's atmosphere was measured for the first time since that flyby occurred, and the results hint at why these auroras have remained hidden from astronomers for so long. Surprisingly, Neptune's upper atmosphere has cooled by several hundred degrees, and the substantially colder temperature results in much fainter auroras that can only be detected using Webb's powerful scientific instruments. This cooling also suggests that this region of its atmosphere can change dramatically, even though the planet sits over 30 times farther from the Sun compared to Earth. These observations were made using one of Webb's powerful onboard scientific instruments known as the near-infrared spectrograph. And for the very first time, scientists have confirmed the presence of trihydrogen cations, a chemical compound commonly known to be created in aurorae. These discoveries help scientists to better understand how Neptune's magnetic field interacts with particles that stream out from the Sun to the distant reaches of our solar system. Webb's infrared capabilities are helping to reveal details that have never been seen before, opening up a window into studying ice giant atmospheres. When Webb's observations are combined with data from the Hubble Space Telescope and others, the picture of what's happening on Neptune is becoming much more clear. Neptune holds a historic title. It was the first planet in human history discovered entirely through mathematical calculations. Back in 1612 and 1613, Galileo Galilei actually spotted it, but he made a monumental mistake. He mistook Neptune for a mere star. Fast forward to 1846. A British mathematician named John Couch Adams calculated where this hidden planet should be. At the exact same time, a French astronomer named Urbain Le Verrier independently solved the same mathematical puzzle. Le Verrier sent his precise calculations to Johann Gottfried Galle at the Berlin Observatory. On September 23, 1846, Galle looked through his telescope exactly where the math pointed, and there it was. Named after the Roman god of the sea, this ice giant is roughly 4.5 billion years old. With a radius of 24,622 kilometers, it is the smallest of the gas giants but the fourth largest planet overall. Its surface area stretches across 7.6 billion square kilometers, and taking a trip around its equator means covering a staggering 154,705 kilometers. It is over 17 times more massive than Earth, and its volume is so immense that 57 Earths could easily fit inside it. Time on Neptune is completely warped. Because it is a fluid giant rather than a solid object, different parts of the planet rotate at completely different speeds. A solar day at its equatorial zone takes about 18 hours to spin once, while its polar regions complete a rotation in just 12 hours. On average, a Neptunian day lasts only 16 Earth hours. But while its days fly by, its years drag on forever. It takes Neptune 164.8 Earth years to orbit the Sun just once. Interestingly, its axial tilt is highly similar to Earth's and Mars, meaning it experiences 4 distinct seasons. But here is the terrifying reality. Each individual season lasts for an incredible 40 years. Imagine living through 4 decades of a non-stop, brutal winter where temperatures drop to a freezing -200 to -218 degrees Celsius. Neptune's orbit also holds a wild cosmic anomaly. Sometimes, Neptune is actually farther away from our star than the dwarf planet Pluto. Pluto has a highly eccentric, oval-shaped orbit that actually brings it inside Neptune's orbit for 20 years every 248 Earth years. The last time this famous planetary switch happened was from 1979 until 1999. Because of this extreme shifting distance, sending a spacecraft to Neptune is incredibly difficult. When our 2 planets are closest, they are separated by 4.3 billion kilometers. At their farthest, they are 4.7 billion kilometers apart. To understand how tough the journey is, it took Voyager 2 a dozen years, 12 years, of non-stop travel through the dark to finally reach the blue planet, while NASA's high-speed New Horizons spacecraft took 8 full years just to cross Neptune's orbit on its way to Pluto. Now let's open up this planet and look directly inside. Scientists believe Neptune originally formed much closer to the Sun before migrating out to the cosmic edge 4 billion years ago. Today it stands as the densest of all the gas giants. At its absolute heart lies a heavy, solid core composed of silicates, nickel, and iron, which is roughly 1.2 times the size of Earth. Surrounding this solid core is a massive, super hot, high-pressure fluid mantle made of icy materials, specifically water, methane, and ammonia. Above this boiling ocean sits the atmosphere, made up mostly of hydrogen and helium, with that trace of methane gas reflecting the gorgeous blue color. But don't let the calm color fool you. It is the windiest planet in the entire solar system, with localized winds screaming at catastrophic speeds of up to 2,100 kilometers per hour, nearly twice the speed of sound. In 1989, a massive storm in the southern hemisphere, known as the Great Dark Spot, was recorded. While that specific storm completely vanished by 1994, a highly similar monster storm re-emerged in Neptune's northern hemisphere in 2016. Neptune also boasts its own hidden ring system, discovered in 1984. It has 5 main rings: Gale, Leverrier, Lassell, Arago, and Adams. These rings are dark and faint, but the outermost ring, Adams, holds a mystery. It contains 4 prominent, stable clumps of cosmic dust known as arcs, named Fraternité, Égalité, Liberté, and Courage. Scientists believe these arcs are actively stabilized by the gravitational pulling effects of Neptune's nearby inner moon, Galatea, and its moons are a story of their own. Neptune has 16 known moons, all named after minor water deities. The first and most famous is Triton, discovered by William Lassell in 1846, just 17 days after the planet itself was found. Triton makes up more than 99.5% of all the mass currently orbiting Neptune. It is a bizarre, freezing world that closely resembles Pluto, leading scientists to believe Triton was actually an independent dwarf planet captured from the Kuiper Belt. The rest of the family includes Nereid, spotted in 1949, and Larissa, found in 1981. Voyager 2 discovered 5 inner moons: Naiad, Thalassa, Despina, Galatea, and Proteus. 5 outer moons, Halimede, Sao, Psamathe, Laomedea, and Niso, were uncovered in 2001. A tiny moon named Hippocamp was found in 2013, and 2 brand new irregular moons, S/2021 N1 and S/2002 N5, were officially announced in 2024. To truly understand the scale of this cosmic mystery, we must dive deeper than the violent storms of its atmosphere and look at what lies beneath. Deep down, at the very heart of Neptune, lies a crushing, solid core. This central engine is about 1.5 times the size of Earth. Making up about 45% of the planet's entire mass, this heavy core is composed of water ice and dense silicate rock. Surrounding this solid, massive center is a hot, highly pressurized ocean of water, methane, and ammonia ices, a vast churning depths of extreme physics, completely unlike any ocean found anywhere on Earth. Drifting high above this hidden interior is a quiet, ghostly ecosystem of dark rings and frozen satellites that we are only beginning to map. 6 faint rings encircle the planet, with some containing mysterious ring arcs, dense localized clusters of cosmic dust particles mysteriously bound together within the ring itself. Also revolving around this giant are 14 known moons, but none are as deeply captivating to scientists as Triton. Named after the son of the ancient Greek sea god, Triton is a world of extreme geophysics. Instead of hot burning lava, its active surface erupts with freezing ice volcanoes, shooting plumes high into space. Because of this strange activity, scientists strongly believe that hidden deep beneath its frozen, scarred crust lies a vast subsurface liquid ocean. To this very day, Voyager 2 remains the only lonely spacecraft to have ever visited these distant cosmic bodies. Neptune, its dark rings, and its mysterious moons still guard their greatest secrets from humanity. But future missions to this cold, unexplored frontier will undoubtedly have many more remarkable stories to tell. The Kepler Space Telescope trails far behind Earth in its cosmic orbit. Since 2014, Kepler has been looking outward along the ecliptic, the plane of our solar system. In this orientation, the telescope can observe the superior planets, like Neptune, which passed through its field of view in late 2014 through early 2015. As we zoom into Kepler's array of detectors, we see the images taken by the telescope during this period, sped up from over 2 months of observations into a matter of seconds. The dot orbiting Neptune is its largest moon, Triton, while the smaller moon, Nereid, trails faintly to the east. About halfway through the observation, Neptune appears to stop its westward march and reverse course. In reality, Neptune always moves east, but at a slower rate than Kepler, which causes an apparent retrograde motion or backward step each time that the telescope laps the planet. The Kepler telescope was originally designed to search for planets in other solar systems using the transit method. When a planet passes in front of its star, it causes a small dip in starlight that can be measured by Kepler's sensitive detector, revealing the presence and size of the planet. During the Neptune observations, Kepler instead looked at changes in reflected sunlight and measured fluctuations. In Neptune's brightness of less than a single percent, caused by factors including the planet's daily rotation, the movement of clouds, and even seismic waves within the Sun itself. By measuring tiny variations in Neptune's brightness, Kepler teased out clues to the planet's hidden dynamics, pushing the limits of its detector and laying the groundwork for more detailed studies of exoplanets in the years ahead.